Hello College Biology, here is our hydrogen bonding video, and first I got to give a shout out to Zachary Rodriguez for pushing me to make this video happen. It's for you. It makes me feel good that not only people are using it, but they are looking forward to the next video, so thanks. I appreciate that. So without any further ado, let's get to hydrogen bonding. Hydrogen bonding is different from the three prior bonds that we've discussed: ionic, nonpolar covalent, and polar covalent. It is different because all three of those bonds, we're taking two atoms, binding them together to make some kind of compound or molecule. This is not the case. Hydrogen bonding does not occur. What is happening? What is happening? So it doesn't occur between atoms. It is an interaction that occurs between molecules, specifically polar covalent molecules. We had to do polar covalent bonds first because they form polar covalent molecules, and polar covalent molecules are involved in hydrogen bonding. So let's review what our polar covalent molecule is. It is a molecule formed from an atom with high electronegativity and atoms with moderate electronegativity. And so they have regions of negative charge, partial negative charge near the high electronegative atom, and regions of partial positive charge near the moderate electronegative atom, because they're not sharing those electrons evenly. Now, when we have two of those together, that's when things get interesting. So, I guess I'll stay over here. Here is a diagram of 5 polar covalent molecules. These all happen to be water, and you can see that they have their regions of partial and negative charge. So all that hydrogen bonding is that when you have two polar covalent molecules together, the partial positive region of one molecule is attracted to the partial negative region of another molecule, and so the molecules will be attracted to each other and orient to each other in a way that allows them to have those regions adjacent to each other. And that's all that it is. Now, if this is liquid water, we know that these molecules are not static. They're moving around, so they might be flowing, but as they're flowing, this is going to turn so that it faces this. But if it continues to flow and this hydrogen region moves past this oxygen region, well, then it'll kind of tilt a little bit so that this hydrogen region will be near this oxygen region. And if we freeze them, then they'll have this like crystalline structure that will maximize this kind of an orientation, so that we go hydrogen from one to oxygen of another. That's it. That's what a hydrogen bond is. Now, we need to note that just because there's an attraction here, that doesn't mean that it's a formal bond. There is no exchanging of electrons, and there's no sharing of electrons between these molecules. This is just sort of an electromagnetic attraction. So, when we compare it to the other bonds, hydrogen bonds are weaker. Ionic bonds are the attraction of two formal positive and negative charges. Well, since these are partial charges, their attraction isn't as great. And there's no shared electrons forming a hybrid orbital uniting the two molecules, so they're not as strong as covalent bonds. These are informal bonds. They are no electrons shared or transferred with each other, which makes them weaker. So let's review. Hydrogen bonds occur between two polar covalent molecules. The partial positive on one molecule is attracted to the partial negative of another. This does not bind atoms together to make molecules, but does attract polar molecules together. This is the weakest of the 4 bonds, as no electrons are transferred and shared. I hope this helps. Struggle well.